Alright, today we're talking about tangent lines, and we got a couple of theorems that we're going to talk about when we have our tangent lines. So first of all, a line that intersects a circle at exactly one point, we call this a tangent line. Now this is different than the tangent ratio. Typically when we're talking about tangent, we're thinking about right triangle trigonometry, and we're talking about the tangent ratio. But this right here is a line that is tangent, and it intersects the circle at one point. Okay, now you have a different type of line that intersects a circle at multiple points. That's called a secant line. So that's that second line right there. You got point and tangent, so kind of going back to tangents, the point where a tangent line and a circle meet, kind of obvious there. And then you have a chord, which is a little bit different than a secant. A secant is a line that extends in both directions forever, that intersects at 2 points, and then a chord is more specifically just a segment that intersects the circle at exactly 2 points, and it's part of a secant line. So it's a segment in between 2 points on a circle. So it's a little bit more specific, and it's a little bit easier once you have all the pictures right here of all the different things. So this first one here in the top left, I guess that right there intersects twice, so that's got to be a secant line. Down here, this segment intersects twice, but it doesn't go past forever, so we call that a chord of a circle. I guess down here, BA, that's a tangent line, so we'll just say tangent. And then I guess point B is the point of tangency. That's really it there. That's kind of a picture of everything there, and we'll kind of refer to all those throughout the rest of the week here. So first thing here, if a line is tangent to a circle, then it is perpendicular to the radius at the point of tangency. So if you have a tangent line, you're going to have a right angle going on. And then there's an example we did before here dealing with the circle. And this is where we had a line that was tangent, and then we were trying to figure out, how long the radius was. And then if you look closely at this graph, the only way this happens is if it's a right angle there. So, all right. Here's another theorem. If a line in the same plane is perpendicular to the radius at its endpoint on the circle, then the line is tangent to the circle. So it's basically the converse of what we had, I guess, before. Okay, here's one that we use, quite a bit, I guess. Two segments that are tangent to a circle from a point outside the circle are congruent. So let's say AB and AC, those are both tangent lines, which means they got to be perpendicular as well to the radius. But that's not the main point. These segments AB and BC have to be the same. So they both have to be tangent, and then they also need to have a common point outside the circle. So that's it on that one. And then we'll use that here in a second. Guess we're going to go and talk more here about the tangent, just one tangent line at a time here. So check this out. You got CB is 3. And then you have CE, the entire thing, is 5. And then they're going to ask us find BE. So we'll call that X right there. And since this is a right triangle, we can say X squared plus 3 squared equals 5 squared. And some of you guys might know that as a 3, 4, 5 triangle. So some of you guys might speed that up a little bit. That's fine. So you do get X is 4. So that's, pretty straightforward on that one there. So when you have tangent lines, we'll use Pythagorean theorem quite a bit, since you're going to have right triangles in this case. All right, let's see what we got here. Given the circle CED, okay, so only this part here is 9, and then CD is 8. All right, and then find EB. And I guess with this one here, some people kind of say, well, they only give us, 2 sides of a triangle, but actually they really give you, or they only give you, like, it looks like they only give you one side right here, but they really give you two, because since the radius right here is 8, the radius going up and down right there must also be 8 as well. So then we can put x down here, we can say x squared, and then plus 8 squared, and then equals 17, I guess. So we'll say 17 squared. Let me double check on that. I think that's 196. Oh, no. Oh, that's 14 squared. 289. So that's 289 x squared, and then you have 64. And then you'll divide, or I'm sorry, you'll subtract and then square root, and you'll get x equals 15. And that is EB there. So not too bad there on that one. Let's see what's going on with this one. Oh, given that the angle is 45 degrees, and then you also have BE is 7. I guess we're going to find the other dimensions, or the other sides of the triangle, so CB and CE. Alright, so they tell us which angle is 45? BCE. So that's 45 degrees right there. Alright, so you have a 45, and then that's got to be 90, so this other angle has to be 45. And then this is a special right triangle. So if you remember from a couple of units ago, the ratio with these triangles is x, x, and x root 2 right there. So x has got to equal 7, so this radius going up and down has got to be 7. And then I guess CE has got to be 7 square root of 2. So that special right triangle stuff, we still use that quite a bit. Doesn't really go away. 7 square root of 2, and then you're done. Okay, let's see what's going on with this one. Another special right triangle. Now they got BCE is 60 degrees. And then BC is 8. And then find the other dimensions. So 30, 60, 90 triangle, the ratios go like this. Always across from 30 is, we'll call that x. So then across from 60, that's your x square root 3 side, and then your hypotenuse is 2x. Okay, and then, so I guess x is 8, so that means that this side down here at the bottom is 8 squared of 3. This other side, that's the hypotenuse of the triangle, would be 16. So, let's see, CE, okay, so that was 16, and then 8 squared of 3. So rather straightforward on these, they're really not too hard. Look at this one here, we got... given that these segments are both tangent to the circle, solve for x. So if these segments are both tangent right here, those have to be the same. So we'll say 2x was 5, and then equals 21 right there. And we'll subtract from both sides. We'll do 2x equals, what was that, 16? So then x has to be 8. And then just double check if they ask you to plug it back in. I guess you could. Well, we already know it should be 21. Actually, never mind. Okay, here's another one here where we use the multiple tangents through a point. So check this out here. It looks like we got these two segments right here. They need to be tangent, or they are tangent, so they need to be the same length right there. So if this left-hand side's 4, the right-hand side's also got to be 4. Now we can use that over here on this next section here. Notice from that point there to the point of tangency, apparently that's 3, so this other side's got to be 3. And it's kind of like a puzzle. You work your way around. Well, this whole entire line right there, that whole entire segment there's 5, and then we got a piece of it's 3. So it means that this leftover piece right here has got to be 2. You can use that on the same side, 2, 2, and then I guess you can say that this side has to be 2 as well. So then you got 2, 2, 2, 2, 3, 3, 4, 4. Alright, and then I guess they're asking to find the perimeter of the shape right there. So whatever it is, you know, however you want to type it in, it doesn't really matter. And then when I got that, I got the perimeter was 22. Yep, so that's it on that one. Let's see what's going on with this one here. Got a bunch more of these tangent lines going on here. I see 8 over here up at the top, so over here on the left side, that needs to be the same. You know, if you need to color code it, it might make it easier there for you. You got 3.9 there, so this other side's got to be 3.9 as well. Alright, if I subtract that from the 11.9, since that's the whole thing right here, that gives us 8. And then this other side's got to be 8. And look over here, I guess we got 3.9 for this side, so this side's also got to be 3.9. So now you'll just define the perimeter, you add up all the sides. And I got 47.6 once I did all that. There you go. That's about it. Kind of short today.